What is up, gang? Well, I did a few things while I was away, coding wise. First, number one, I got a job. Yippee! Number two, I worked on the compiler a bit. Yeah, so actually quite a bit. I'm getting really close to the fun part, but I just need to do one more thing, which is fuck with LLVM IR, intermediate representation, which is gonna be fun. Second. Okay. So, yeah, I need to figure out. So, I had to do some. Well, actually, I did two things, right? I implemented the AST, I scrapped the CST stage because it's useless. I think it's useless. So, I went from the Lexa, the flat array of tokens, straight into an AST. I'm not going to do semantic analysis yet. Yeah, I'm just gonna go straight into the turning it into yeah. So yeah. So I need to figure that out. Let me show where am I right now. Where are you? Boop. So this is what I did. I have a nice pretty AST thing. Gets tokens, gets program, inside program there are declarations. Right now I only have function declarations. I don't have any globals or nothing. So I just put it like that. Function declaration. Here we go. This thing here. Something's wrong with my keys, but it's okay. Yeah, bunch of stuff. I just realized that function is way too high up. Wait, what? Hold on. Plus expect. Oh no, sorry, no, that's meant to be there. Yeah, okay, yeah, I remember how I put this format of this. So I have that, and I did some finagling to get this LLVM thing going. I tried building it, and then my computer ran out of memory, literally ran out of memory. So I had to do some fancy build to get as minimum a footprint as possible. It's quite small, but the actual code base is something like 3 gigs, which is so annoying. Yeah, so that's working. I now have a nice import. Where are you? I'm a little bit suspicious on oh no, don't be like that. Okay, that was a bit spooky, but I've had that happen before with perfectly fine code. So I think it's just my code. Oh god. Whatever. If it happens again, I mean, address sanitizer should be picking it up, but whatever. So anyway, I have this nice pretty import here, LLVMC core. I'm probably gonna copy over this file because it's in the middle of nowhere. It's in let's try to find it. Directory do copy. So actually, let me try to figure out how to use diard. LLVM. LLVM. Lib ir. Sorry, no, I want the header files, right? Include. There it is. There it is. So I want to copy over this folder because this is all of the things I built, I believe. Yeah. So let's see. If I mark it like this, diard do copy. Okay, I want to copy LLVMC to. Oh, that's cool. That's cool. I want to copy it over to wider source include. Done. So if I go here, hit it with one of these, refresh. There it is. Cool. So now if I go into my internal this thing, I should be able to just jump to it, right? No. That is annoying. I mean, I can do so I really need to like just spend a while learning this. Rename. Can I do this? Okay, whatever. I'll just do that include. Can I do that? To LLVMC. Can I do that? Yeah, perfect. So now this should work, right? Good. Nice. I'm probably not going to commit it. I'm just going to do this here. Dot get info exclude LLVMC. Yeah. Does that work? Can I do that? Yeah, good. It's being ignored. Okay, we have that. So what do we need? We need a thing that's going to take an ASD program and output something that we can do some building on. Some IR, I don't know what file, what kind of data type it is. And then using this IR representation, I compile it using their fancy Clang thing. Yeah, that we have to figure out. It's fun. So I'm gonna assume it's somewhere in here. Great. Pretty sure there's a context. Create context. Create new context. LLVM create C. LLVMC API. Create context ref. What is this? I don't have it. Okay. That's not fun. Okay. That's really annoying. Not being able to see into this. Context. I mean, I guess it's not a struct. I assume it's like a size D or ID or something. I'm not sure what this is. LLVM Oh, there's the data types. Okay, that's something else. Let's cast something else. Types. I see types. Opaque, a bunch of opaques. That's fun. Is that context in here? Context. Opaque context. So do I have you? See, LLVM context class. Oh, is this C? Oh yeah, this is a C++ code base, right? Let's see, LLVM text. So, okay, I see. Okay, so let's create a file. Let's call it. What do you even call this? What do you call the step of lowering AST to IR? Okay, maybe this is a word I can use. I can just call it IR. What was it? Corech. Oh, I can't. That's annoying. If I add it to my exclude, I can't search for the header file easily, which is. I should add something for that. Create context. And I can't control O out. Something's wrong with my. I'm gonna close Emacs, and I think something's wrong with my control O. IR. This doesn't come up right yet. There we go. Control is not working. I'm not sure why that wasn't working before. I want you. I'm not 100% sure if this is what I'm meant to be using, but it looks like what I'm meant to be using. So I'm just gonna just make a little thing that just to test stuff with, right? Let's add you to that. Okay, so we have an IR. What are we meant to do with it? Ooh, sorry. Let's search for create. Okay. Let's say add address. Let me see. Uh, am I mad stupid, or is this kind of hard to use? Let's see. Pretty sure you need to like set some variables, but if I can't see, okay, let's keep that open. LLVM context example hello world. LLVM hello world example. CPP. Hello Zilder. Holy. Okay. This is kind of what I want, I guess. Alright. Fuck off. 1 million includes. That's fun. I assume there's a proper way. Function etch. Constants. IR builder. I guess this is what I want, right? IR builder. Where is it getting it from? LLVMIR. LLVMC IR. Is there no IR folder? Write module to file, that's cool. That looks pretty easy. Oh wait, he wrote it. Okay, this is ELL file, yeah. So it's all here. Create main function, string constant, create puts, invoke it, return 0. Create a return builder, create. Int 32, I think, and then it's set to 0. Is that what I mean? Something like that. This is probably like a macro. Well, I guess it's C++. I actually don't know what the fuck is happening here, to be honest. Okay, let's see. I guess we have to find a module. Module. Oh, nay. LL. Where did it go? Did I not have it a second ago? I'm in core. There it is. Okay, so we have create context, get diagnostics. Do we have function? God. Oh no. LLVMC sample hello world. This is C++, C, LLVMC API. This is C++ again. Okay, here we go. LLVM module create name in context. Okay. All right. These are the types, and we're giving it this thing. Okay. All right. Okay. Cool. I guess you can scope things like this. Context. I'm not sure what this is exactly. Why? With this okay, whatever. Puts function, puts func arg type. Type ref. It's an array. Oh, that takes in this thing. Okay. Okay, let's just do the bare minimum and see what's up. Okay. We need you. There we go. So we got the first one. Hell yeah. Let's call it root. So we have these types. So let's return a uint32, right? Actually not sure. It's just a u8 because we have a u8. Puts function type, main function type. We create a function type and then we register it somewhere. Append basic block in context. Yeah, okay. Entry. What is entry? Is that like a reserved word? Create build it in context. Even type in context. LLVM add. It says add function. Wait, are you adding it to anything? Okay, you're adding it to a module. And you're giving it this name. I'm wondering why this is not just in here. Whatever. Okay. So we have our main function. Let's quickly check what you are. LLVM function type. Here we go. Obtain a function type consisting of a specific signature. The function is defined as a tuple. The function is defined as a tuple of return type. Okay. A list of the parameter types. Okay, I see. And whether the function is Vardiac. So, okay. Look into Vardiac later. So we set that false, right? So So what we did, we set it. So I want to set. We'll do 32. Change it later. Param types we have none. Param count is 0 and his Vardiak is false. Okay, let's comment that. So we'll look at it later. The add function. So we take a module. I have to Google what a module is exactly. I think in the IR setting at the top, I think I've seen it before in like the actual IR code. But I still don't know what it is, to be honest. So we have main function type, we have this thing, we add it to the function. And then LLVM append a basic block in context. Context, main function, entry. LLVM position builder at end. Entry, what is this? Is this like a reserved word? Oh no, it's this. Okay, I see. Okay. Let's check what this does then. Whoa. So let's look for you. Whoa. Basic block in LLVM append basic block in text. Append a basic block at the end of a function. Okay. So does it like oh, so the build is like kind of like a point, like a when you add stuff, you want to increment it to put it like after it, and then like if you get a new function. Oh, wait, where did I get builder? Great. So it starts with that builder in context. Okay. So you get a context, and then it's like at the top, and you can declare stuff one by one, and you move the builder down as you declare stuff. Something like that. I'd have to see what it looks like. It's all builder refs, all references. It's kind of annoying. Okay, whatever. And then LLVM position. LLVM position. Oh, so there's a bunch of functions here. Positions builder. Let's look at. There's a bunch. Okay. Create builder is deprecated. Use context. Okay. I see. Position builder. So the builder position before instruction, but after any attached debug records. Before debug records called position builder before at end basic block ref. So block ref is this. Okay. At end, I assume that's inside, at the end of a function. I think it's inside. So we're inside of the main function, right? The entry, basic block ref. Append basic bucket, got it. Okay. So if I call this right here, bang. Whoa. LLVM position builder and build rep builder LLVM constant. Okay, so that's how you declare a constant. LLVM constant. Okay, it's starting to make more and more sense. It is sane, I think. So far, looks sane. LLVM print module to file, dump module to std out. I assume that's what it means. Okay. Clean up, clean up, clean up. Okay. Cool. Oh, do we need to call the build? Build call 2. No. Okay, let's see. This is the clean print module to file. Will look at me and no. This should just work because I haven't actually added it to the file. I'm just checking whether or not the rest of it is working. It's like it is. Okay. So ir.c, make file. A file. Undeclared false. Oops. Declared false again. And we're building. All right. So let's call this guy. Let's call you here. So what are we expecting? Let's stand it out. There you are. Look at that. Look at that. So I assume I can now just compile it, right? Ladder. So you're there. Yeah. So I can just do like clang, look at me LL, and then taco output out. Taco. There you go. Cool. Okay, let's look at it one more time. So, create a context. We module create name with name in context. Okay, so I'm not sure exactly what that is. But whatever. We have a builder thing that we can use to add functions and whatever. Using module, adding a function to a module. What is the builder for? We use the builder to actually write into it, right? LLVM builder return. Oh, okay. All right, this doesn't look that hard. Famous last words. Cool. I want to look at this again. Module ID root. That's what okay. Root source file name is root. Source file name. What was the error? It said overrun the module target triple. Okay. Look at me. Entry. Oh, is this a label? So can I remove this? Okay, let's just see. ir.c. So Can I do that? No. Basic block ref, basic value ref. I mean, I guess we do need an entry, but am I doing this correct? Cool. If only there was documentation for this shit. 11 print module to file. Is that? I assume that's good. Okay. Thank you, mysterious man from GitHub. That's cool. So how do we? So we need. So let's go to you. Just do IR. IR create. It's going to take a AST program. What do you want to return out? For now, let's just tap it to a file. Now let's just stand it out, fuck it. So we have a bunch of steps. This is, you can see how this is gonna get quite annoying. Even with such a simple thing, I have there's so many layers. So basically we need to go to this. Okay, I don't think this is that hard. So let me just yoink this guy here. Okay. Start with program. So we have a program that looks like this. Groovy song. Okay, so let's see. So we want to do the first stuff here. We want to create context, create a builder. Yeah, let's do that. All right. So we have this. We have our context. We have our doodads. I still need to check what this actually means. Let's do. Okay. So we're gonna go one by one through the declarations. So we're gonna have like a step process. So parse declarations. So can these be globals? because I don't think we're going to do more than that. So, okay, so pass declaration. Pass declarations. I guess we should do pass program, right? And it's going to go through one by one of the declarations, and then it's going to be a pass declarations, and then pass function, pass blah blah blah. So, all right. So we have our context for everything, and then I want my these guys here. So I guess we have to do one special thing where if it's the main function, we tack on the entry. Is there a get? Is there a way to get the base? Oh, okay, so this is like a function signature, and then we append like this squirrely is how I'm thinking about it. If I do does this build? That's there, but I need this. So cat look at me. So we have that. So if I do clang look at me out, it's gonna say no entry. Okay, let me just let's do one. Then line. I think that was an error. Yes. So what? How does it know? Is this like a reserved name? Main? LLVM IR is main reserved. So for this append basic block, can I just do that so I have a unique thing every time? Maybe I have like a stringify function. I guess I can just call it, right? Whatever the name of the function is. Okay. See. Okay, let's see. So we're not gonna sorry, we are taking the program. And we are taking everything that's in it. So LLVM. Sorry, do we use the context ref again? No. Oh, we do. We do. Because like, are we ever really? Let's be real as hell. Are we ever really fucking with it? I don't know. I guess we'll add it. I guess module we might be changing it. Like our program, we can split into whatever thing I'll do later. But context is definitely the same. Let's do that. Whatever. Module builder. Module ref. And LLVM builder. I guess we can just do like program builder. We could just pass this guy around. I think that's a little bit nicer. I mean, wait. What is a module? LLVM IR module. Module structure. The LLVM program is composed of modules, each of which is a translation unit. Okay. Each module consists of functions, global variables, and symbol table entries. Modules may be combined together with the LLVM linker. Okay. Why is it lagging when I'm highlighting? Is this page big or something? Must be. Which merges functions and global variable definition, resolves forward declarations, and merges symbol table entries. So here, he's not. How is he doing that? See, there's no label here. I need to figure that out first. Okay, I'm pretty sure there's a way for it to take this. So let's do LLVM position builder at the value ref on. Set the build position before. Okay, position builder. If set the position of block, or if LVM insert into builder. Get insert block. Oh, it's somewhere in here. Set builder position before insert. Okay. Let's try this one. Let's see what it does. Segfault. You know what? Okay, what if I just don't call this? What happens? Nothing happens. Okay, so we need to position it somehow. So we need to use this somehow. Append basic block in context. I assume it's somewhere near here. Something that takes a value ref. Right? LLVM append basic block in context. Create basic block in context. Create a new basic block without inserting it into a function. Is that what I want? Oh, so I don't have a name here now, right? Wait, what? Wait, what? Not quite sure. No, okay. close. LLVM create basic context. Okay, here we go. Get entry basic. Oh, so this is what I want, right? So this takes a value ref, which is our main function, and this is our entry, main function entry, something like this, and then I do that. Oops. Fuck. What am I doing wrong? Oh, okay. Okay, I need to insert the given basic block. So it doesn't exist, that's why it's crashing. So I need append to get the given. This looks like what I need. Create a new basic block without inserting it into a function. Oi, oi, oi. The function is to function to add is determined by the function base block. So the base one using global context. Deprecated. LLVM add block to function. LLVMC. Let's see. Because here it's doing it without one. There has to be a way. Basic block. Any example? Any examples? No. Ways to insert basic block. Okay, here we go. What is this? New. Hello, Marmite. You're still here. Channel. Basic block create context name. Insert into. So I don't want a name. Returns. So I can create a block and then insert it into a function. Is that what I can do? Oh, so can I pass null? Wait, I'm stupid. So if I do I do that. No. Fuck. Oop. Mewtwo. Alex. Insert into, and it takes a basic block, but I need to create one. Append, okay. LLVM C append block to function without label. Is that the same link I clicked? Yeah. Create a trash file without. Take your time. Close. I'm trying to find someone who'd be interested in making OS, aka creating operating system. Would you try to make OS? I actually have already made an OS. Very basic one just to learn. Why isn't this autocorrecting? Marmite jar. BOS before. Would someone who would be interested in making OS, aka creating operating system, would you like to make an OS? Damn, sorry I didn't have the chat open for that. Whoops. Whoops, whoops, whoops. Okay, here. So if what, okay, instead of now, let's try that. Let's see if that works. It did work. There we go. That's all I needed to do. Okay. Fine. You win. Let's compile it and see. Yes, please. Looks good. Yeah, looks good. Cool. So we have that now. Sorry, we know we can do that now. I really should have the chat open in my whatchamacallit. What do you call it? On my phone. I forgot the word for phone though. IRC. We'll just call it that for now. So we have a parse program. You can pick a program, module, and builder, right? So I'm wondering if I need to keep this separate. Because in the future, let's not worry about the future. Let's not worry about the future for now. Let's get the overall vibe down. A little bit of context. Still format. You're gonna format that, Brody? There we go. So what do we do? Program, context, module builder. I guess this is needed if I don't know, man. I don't know. I guess it would be kind of useful if I want to in the future do like C API. What do you call it? So I can run like do like extern C's type shit. You know, like most languages have to deal with C. The word that is C. Anyway, so we have a program. So we're gonna go for size t I equals 0, I less than program. Program dot count I plus IR parse declaration, and it's going to pass program items I like this. Does that look fine? I think it looks fine to me. So then yeah, this is hella clunky. I would not mind using globals for these for now, just so they don't look fucking stupid as hell. Nah, let's just keep it. Declaration. So we have AST declarations, right? Okay, and we look like that. So right now declarations look like this, and we only have function declarations. So declaration IR parse function declaration. Let's do declaration dot no, I'm returning. Was this is pointed to declarations, right? If I remember correctly. Pointed pointers, yes. Yes, sir, pointers. Okay, so dot so as of and then our name. Maybe I should make this a type just so I can just boom, pass the struct easily. But maybe it is. Maybe instead of pass, we do create. Or add. So we do create program and then add declaration. That's a little bit more nice, I guess. For now, let's just explicitly. for the compiler. Doesn't really matter. It's just for my sake, to be honest. Name. Oh shit. We also need Alexa tokens. Tokens. That is fucking annoying. Okay, in the future we can speed it up, but for now, Alexa tokens. Oi, oi, oi. I just realized that is really ugly. I need to keep around this gigantic list of Alexa tokens all the way to the very end. When I should just be like saving the little identifiers only. Right? Yeah. Oh fuck. Okay, I'll do that later. For now. To do urgent. Oh fuck! I forgot to start my timer. Okay. To do IR. And we started when? An hour 15 ago. Quick math. Okay, sorry. All right, so we have I guess we don't want to be shipping over. Oh, it's appointed to Alexa tokens. Wait, no, Alexa tokens. Okay, so we should not. We should be doing that. Yeah. This is, oh, lordy lord. Lordy lord. Oi, oi, oi. Okay. Okay, fine. Okay, just for now. We will change this later. Probably in the Alexa stage, we're gonna have like another array that will be a little bit longer lived. That will just contain the literals and identifiers. So we can throw away the other tokens as soon as the AST step is done. And then we use that. Yeah. We'll do that. But for now, add function declaration. Did I do that correct? I think I did. All right. And body. Oh, so we need to create a body, right? So IR create body. Is there any other case we need? Because we have in the future, I assume AST block we will need it for if statements and whatever. So maybe we create some function that creates a block and then we pass that block into this thing. That will kind of model what you can put into each function instead of it being one of my own AST types every single time. Maybe inside the function block I can do that. Yeah. So func body. All right. Func struct AST block. Okay. Void declaration struct AST. Sorry, what was return type? Token ref. Yikes! That is wrong, right? That's my token AST U8 return type. Ooh, lordy lord. Ooh, lordy lord. Okay. Okay. token refs might not have been the correct choice. Let's do contact. Token ST identified. Hoi 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 hoi. Oh, I should in the AST thing. I should have resolved all of these, right? Technically, sorry, not technically. I should have, right? I should not be able. I should not have to have do all this token shit. AST. Let's see where I set return type. So instead of storing a token ref, yeah, this is garbage. What I wrote. This is stupid. I should just be able to do program items, this thing, whatever, as func return type is equal to this type. I should not have to search through tokens to find it. Should just be a value. Oh no. Sometimes you'll have return types that is user defined type. So token tag. Yeah. Okay. Nah, this is fine. This is good. Well, I don't know if it's good, but it's something. Mouse, hello. Mouse has died, that's fun. I mean, especially this one. No, I think this is fine. That is hella ugly. Because that means this thing is going to accept the Alexa token tag. Um, have I fucked up the AST? I thought this was good until a second ago. Hmm. Oh nay, oh nay, I think I made a big mistake. Actually, no. So right now, since I don't have any custom types, this is fine. So in like after a while, I'm gonna have a type. It's a struct that's gonna be like types, right? And then I'm gonna have like a past types thing, right? So for now, it doesn't matter. I foresee a large refactor in the future, though. I mean, I should just be able to throw away technically the Lexa tokens. I'm gonna fix it right now, actually. Hmm. Especially this function name is taking a token rep. I should function declaration. I take a token rep and then I think I alloc some stuff, right? And make this function declaration take a name, right? And then this has to be its own type. Because the Lexa tokens, those are just keywords. In this context, it means a type. So just change this one thing for now and then see what's up. So AST alloc. So let's get. Oh, we don't have access to the Lexa names. Lol. play some that guy there, DNB. Oh, I'm just sorry. This is returning a and this is taking a ASD token. Right? Losing my mind a little bit. Little bit. VCAT. Alright, let's go back to where we were. Bang. Okay. So now we have the name. So now this takes a construct star. Sorry, this takes a. I have a special thing for this. Right? What was it? Let's see if we can. ASD identifier. I guess we should just malloc size of name and just mem copy the whole thing, right? Because it's already null terminated. Sorry, I have mega gigahertz. Wait, this is allocated. Okay, sorry. Instead of this, maybe I do ASD identifier. Because then I do not need any mallocs. Much nicer. I don't know what I was doing before, bro. Ignore me, bro. So this will just fail. I just need to. It's only failing in the tests, right? Good. All right, let's see. So this one, we don't need to check if it's an identifier. And now we don't need to do this thing here. Or do value, right? Good. And same thing here. My brain is working overtime. Holy fuck. Okay, and then same thing here. Yeah. Array type ASD identifier. I guess I can just do memcopy. Destination and whoa. And then I have unexpected type pass or Sorry, what is the error? What are you yapping about? I was always be complaining, bruh. Function identifier token. Function identifier. Usually Clang tells me whether or not I'm close enough to a variable. That time it didn't, just kind of weird. Yeah, I did mean an arrow. Yes, I did. Maybe I didn't copy it over correctly. Where did he say it was? I should add logs in here so I am able to jump to the... Like here, I should be able to just jump like when I build. I should add that. That would be so nice, actually. Why isn't it working here, actually? Whatever. Let's see. Line 104. Okay, let's check it out. Function token. Okay, yeah, wait, make build. GF build debug test break. ASD parse function check. It's sad that it's not. There we go. All right, let's see. That's where our parser is at. Okay, good. We have U8. So we're at token 1, peek at. I assume it's a problem with peek at. Function identifier. Oops. Bang. Main. Alright, it got it. Okay. So we should have name. If we cast it to a star name. Main. Alright, good. Let's see. New book. Name is there. All right. So it's a bunch of 205s. Good, good, good. Set the kind. Set the return type. Now this guy here. Oh, You know what? Dude, all my bugs come from me fucking with conventions every single goddamn time. Where are you, memcopy? Dot name. Let's just start this thing. Name. Oh, lol, I did it to the wrong side. Oh, well, I guess both. Do I have stupid brain? I think I might have stupid brain. Oh, all the test spots, cool. Cool. Good. It was just that. Alright. Cool. Pop one with that done. What else do we want? So I have identifier and return type. So I want to do some kind of type struct. I don't know. So I'm actually only using it there, which is fun, which is good. Let's see where I'm using this guy. Fucking everywhere. Where are you being used? So why did I not choose to use this? So I guess this should also... Oh, that is a bit lucky. Yeah, yeah, I really should not have just. Okay. Okay, it's the last one I need to do. So parser AST parser peek at every goddamn time. Beginning at the point though. Poop. Good stuff. So then I think this last place is just the types. Wow. So, okay, I mean we can just see, I guess. Yeah. You change it to this. So it's just here now, which is cool. For now, let's just make it an enum. Type det enum AST types So it's not typed effort. AST type U8. I guess just that, right? Oh. No. So in the future, I assume pretty quickly that's going to change into a struct where I have to store like how many bytes, the offsets and stuff. But for now, we'll just do this. And just see where it crashes. So let's... Where are you? Alright, here we go. Uh-huh. Oh, I guess we still do need what? How is that passing? In the future, it's going to be like a get type and it's going to be a whole thing, right? But for now, it is one line, which is sick. I guess we just hard code it. Oh no, so this is different now. So it needs to be like this. Right, and then you wait, see these other ones. I really need some kind of quick fix thing, that'd be so nice. Pretty sure these are only passing just because, like, if I run a debug, it should crash. I mean, we can just test it, right? Test debug. Should be getting some kind of crash. Yeah. Bunch of offset reads. Yeah. Why is it exit 0? A lot of misaligned it. Yeah. Good. Good. I wasn't going insane. You wait. Uh-huh. Yeah. Boy. A few more. Alexa UA. Using it there is fine. That's no good. The hell is this? Call to function sign check to pointed to incorrect function type. Okay, here we go. Enum, yep. Store to misaligned address. Is this some union shit that I did incorrectly? No. So the first thing is the return type, which is U8. And the error is happening where? Error is happening. There. So it's inserting the body. So I assume 60616996E is main, and then the null terminator 00. CDCD 000000. An enum is 8 bytes. That can't be right. So okay. So it's writing to this, and then my thing is 31, 32, 31. Okay, first of all, that's inefficient, but like, let's just try to figure. This is weird. Requires 8-byte alignment. Ooh, lordy loo. Load of misaligned add address. Okay, what is the first error? Why is it erroring here? That oops. Um my sanity check is fucking me over, which is fun. I hate that this is pausing. I think all those other errors are just because of this first thing fucking up. And I have done something stupid. How have I done that? How have I done that? This call is being sussy, apparently. I'm gonna be real, I've never seen that in my life. I might need to... Anyway, so inefficient as heck. Because it's not that bad that it's inefficiently packed, just because where... Oh no, it actually doesn't matter because it's in a list. Maybe name should be outside declaration kind function, or a name assign. All right, give me 1 second. I'll be back. Whoa. I'll just do that. That's fine. A bizarre error. Ooh, turn on the music, it's kind of loud. There we go. All right. After consulting Mr. Kimi.com, the Chinese AI, I suspect it is because of my custom allocator. The fact that it only comes up now is kind of funny. Just because the enum is fucking with some offsets. That's my guess. It was kind of glossing over it, but I'm pretty sure it's that. Because where are you? This I'm not sure. I know there's like this thing to make your enum small. Huh. Wait, am I allocating? Yes, I am. Yeah. I never had that error before, so that's kind of cool. Yeah, it's coming from my bump allocator. Ooh, I never used that. I've never used that directive. Aligno. D99. Aligno. Aligno. That's cool. That's cool. I never used this. I never had the have to. Blah, blah, blah. I never have had to use this, which is cool. Let's see. Uh-huh. That's fucking sick. I've never had to use that. I'm using C99. Can you use... Oh. Ooh, it's a C19, C11 thing. Line all C99. Cool. So this is from offset of. So that's maybe I bump up to C11. I'd rather not though. That is a neat trick. That is neato. I've never had to fix this problem. Okay, let's try other stands properly. So a line of 8 bytes, 64-bit, right? So hit 8. Mask, that means is so I'm trying me box. Okay, let's see. So if we have 8 is 1, 3, this thing. What is it? 1, 2, 4. 4 plus 2, 7, 8. So it is 1, 0, 0, 0. Ooh. Minus 1, so we get 0, 1, 1, 1. aligned offset is pool offset. So let's say we're at 3 by 3. So that looks like 0, 1, 1. 0, 1, 1 plus this thing, which is 1, 2, 3, like that. And we are ANDing it with not mask, which is 1, 0, 0, 0. So then we get 1, 0, 0, 0, which is 8, which is aligned. Cool. Neat. That's neat. Baller, baller, baller. I fucking wrote a comment for it too. Ay, ay, ay. Ay, ay, ay. For fuck's sake. The comment. I guess we're getting much less errors, but we're still getting the one at the beginning, which is a bit weird. This is a neato trick, actually. I like this. Neat, very neat. I like that. Anyway, is there anything else it wants to tell me? Have this that's a separate issue in your test framework where sound check is being invoked through a function pointer. The wrong signature, it doesn't crash your AST test, but you may want to fix the AST test group packager or register code so that code signature is the same. Huh. I don't. Looks fine to me. That shouldn't be there. Did that? No, I didn't fix it. Define. I'm not sure why that is breaking there. That is really weird. I've always done a sanity test at the beginning of my tests. I guess for that reason, but like now this is failing. What the fuck? I didn't had my sanity test fail. What the fuck? Oh. No. No, that was hopeful thinking. So weird. Very weird, very weird. Boss, 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 boss. Is that not what I did? RT test. Etch. Boom, boom, boom. Boom, boom. I guess that fixed it. I did not know that causes errors like that. I always thought you could just do void. I've never had to fix that. That is cool, I guess. Okay, anyway, so things we did. Okay, where else are we using token ref? Token. I guess we should remove this from here and move it into AST. Parser. Not sure why my compile time is so long. Because I really should fix my testing framework. I coded it when I was stupid, and it is so... I mean, you can see the allocations that's required for it. It's stupid. Anyway, so we have that. We fixed that. fix. Okay. Stage you. Refactor. Remove token ref from. Wait. From ASD. Structs. Do that. Yeah, that's much better. Yeah, that is way better. TBH. Because now, yeah, there's no need to do any fancy fucky wucky. Let me just see tokens, just in case. Make sure I'm not doing any of it in the ASD step, which it isn't. Good. So technically, well, I can't fix it now, but like I can test it fully when I implement the IR step where I free the Lex tokens, and everything should be fine. Okay, I think that's enough for today. We learned a lot about C, I guess. Fuck, should I switch to C11? There's just so much helpful stuff there. I don't know. All right. See. Wait. Let me. Next. Good. All right. I will see you all tomorrow or soon. Bye-bye.